afternoon. How are things?
Good.
Hi, good. So today we'll continue with the synchronization stuff that we were talking in the last lecture. Do you have any questions about what we covered so far? So one of the things that you may notice is, it's still, I'm talking at a very high level, I'm not going into too much detail on how specifically you do any of those things, right? And there are two reasons to that. One is many of the things that we talked about essentially boil down to how you put them into an editor, how you put them into some automated tool to annotate those stuff, right? So the concepts we talked about in terms of timing and event-based and all those things are something that in abstract sense, but the reality is you have to put it into a system, right? So that's one component of it. So we'll see two systems which you probably use. I referred to it in the class before. You've probably seen it a lot, and I want to show what exactly is happening in some sense, right? The other thing is, from a system perspective, making sure these things are synchronized is very hard, right? And it's an active area of research. So I'm going to show at least two projects, actually three projects, which have been attempting to do some of this stuff. So whatever we talked about as something that it'll be good, when you have multiple streams trying to correlate them, make sure that they're synchronous and all those things. The system that people have been working on for a few years, attempting to address some of the little problems here, right? I don't want to go into any detail of any one of those because each one of them is way beyond the scope of what we can cover because it gets into nitty-gritty detail. But I'll give a little bit sense of where the state of the art is, and these folks made the videos available, right? First is the thing I mentioned about YouTube, right? YouTube, if people have seen YouTube, I'm hoping, and essentially YouTube, what it gives you is it gives you a flash mechanism where the YouTube folks program the stuff, right? So the flash does not give you this window. It just gives you a little area of the screen where you get to program whatever you want, right? And the way you program that, YouTube folks decided to have these kind of buttons here. And when you press those buttons, it goes into flash and you react to it, right? So the flash lets them play the video, but all the other interactions are an artifact of what the YouTube folks decided, right? And we'll see some of the cases where you can interact and see the synchronizations going on. The first one is the notion of annotations and closed captions, right? And I'm choosing my own video because it's sort of safe because some of the videos in YouTube may not be appropriate for in the class setting, right? So in the annotation editor, the idea here is we can as a collaboratively add stuff, so we can kind of point and add stuff. So at this point, I can say something about what I was talking about as annotation, and if I give permissions to other users, then you guys can add annotations and so on, right? And this is one of the things I was hoping that we would be able to do through the Google Apps, which is where you get your email. So we had to be able to do that, but for some reasons it's not working out quite the way we expected, right? So essentially, I'm going to show you like some of the things that you may have seen it and what all this synchronization means, right? So in the simple case, we have to have all these buttons here. And when you press these buttons, you expect something to happen. For example, if you press this little rectangle thing, you expect it to play. So remember in the synchronization stuff, when after you press the event, after the event of you pressing the button, something has to happen, right? And before that event happens, it's showing whatever it said it is. And you have all these other buttons, and each one of them changes the behavior in a synchronous fashion. It's in a synchronous fashion because I don't want it to play till that event happens, the event of me pressing the button, and then this event should happen, right? What synchronization allows you to say is to say precisely how long or how these things should. I guess somebody went to sleep, right? So how long things should happen after I press the play. And in the case of the play, you don't really care how long it takes for it to start playing after that. But in the case of annotations, you'll see that if it goes off into something else, you'll mind, right? So let's look at the screen. So the way that So when I go to full screen, it doesn't let me edit the annotation. So when I play this stuff, so I added this text, right? And it just has my name. But if you had something here about what I was saying at this particular point, your synchronization primitives would be at that instant. So you'll have to say in this stream, after whatever I was saying at this point, you want this particular thing to be displayed at a certain instant. So that's the interval-based scheme that we are talking about. So if you use the interval-based scheme, you would say after whatever I have said so far, you want this particular thing to be displayed at a certain instant, and then at some point you want it to go off, right? So you may interact with it and create this using editors, but what you're really doing is you're specifying the time when things happen. You're specifying what precedes it, what should happen after that, and once you do this thing, you want this to go on, right? And depending on the kind of application, you want this to sort of happen when I'm there, right? So in this case, I don't actually move off, but if it is some kind of movie or something, you don't want this thing to be so off synchronization such that the next scene where I'm no longer there, you don't want it to be pointing there. So that's the notion of you having the synchronization stuff, right? And the next stuff happens towards the end. So it doesn't let me control more accurately, but I'm waiting for this stuff to end, right? When this ends, U2 by itself has some primitives which say at the end of this event, something should happen, right? And something happens to be these set of things. So they decided that these were related to the video, right? But what you have to, I don't know why Econ was related to this lecture, right? But for some reason, we are both talking about synchronization, right? So they decided this stuff, right? So what you see here is the artifact of what you would have to specify, right? You have to specify that after the video ends, after the time reaches 5013, somehow you run some algorithm to figure out what these different stuff are. And now you have to decide that these things have to be at certain, which part of the scene they should be, what goes here, and now you can interact in a certain ways. You have the share, replay, and all those things. Those are the ways you see the stuff. But essentially, what you're trying to say is, after the event happened, now you're in a new screen with a new set of events, with a new set of synchronizations. And when you click on one of those things, you go away. And the model and specification we're talking about was essentially how do we, in a formal sense, describe what happened, right? So you figured out that these videos are related. How do you show them? And I think they also do, like if I hover over one of those things, the video actually starts playing. Yeah, if I hover over for a little bit, that little icon starts to show some frames and stuff, right? So what is not important is how they did it and what they decided to do. What is important is trying to formalize how these specifications are specified, such that you can verify that things are happening, and you can verify that things are not going the way they're supposed to. Not in the terms of the content, but in terms of being able to verify that your experience is what you're getting, right? So that's one of the systems that you would have seen it, which has the notion of the primitives, the models we talked about. The other one, which I mentioned, was the DVD, right? Unfortunately, I forgot to bring any other DVD, and this is the only one that my son watches, so it was in my car. So when you watch movies, right? So DVD movies are all about playing your movie. But it's not just playing movies, right? So you do interact with the system. The system has to specify what the different parameters and what synchronizations are. So what it is, so you have this sort of a menu, right? And you have some video playing in the background. You have the car scene going on in the background. You have this way to interact all these things. So you have to specify, in some sense, through some editor, what those different parameters are, what gets played in the background, what gets played in the foreground, and all those things. But I changed the way things happen. In this particular case, I can go to setup, and I change the audios I can choose. So I can. So in this particular case, there's only English, but many videos you would have seen, they have like French and Spanish and stuff. So you click, you select one of those. Let's say I select one of these. And these are all event-based system. So I'm using a mouse, and if you're playing with your
More recently, we had the great pleasure of showcasing our technology at the Gala event at the Fall 2004 Internet 2 member meeting at the University of Austin in Texas. In a very exclusive experiment, the Miro String Quartet performed live in front of an audience at one of the venues at the university. The stage was instrumented with multiple high-definition cameras and many different microphones. We then captured the environment of that venue and we transmitted 4 high-definition video streams plus 10.2 channels of sound from the first venue to a second location where it was rendered for the second audience. The quartet was performing their concert and the audience was swapping locations during the intermission.
We're glad you could come for what's going to be, in my view, an absolutely sensational evening, the likes of which you've never seen before. Or heard. You are members of the Orange Group, and I am the Master of Ceremonies for the Orange Group. The first half of the concert, the Orange Group will witness orally and visually in this room, and I'm here to tell you that the Miro Quartet will really be on stage. Then I will lead you all, during intermission, to the McCullough Theater, which is about 150 yards in that direction, and the building immediately adjacent, where there's another audience over in McCullough right now. The Master of Ceremonies for the Green Group is Vice President Updegrove. So you'll see Updegrove coming in this direction while we're going in that direction, but once we all get into our new seats, the second half of the concert will begin, which you will experience virtually. This has huge implications for the future of touring musical and artistic ensembles of all kinds, as you can easily imagine, which is to say, it's one thing to play a concert in Seattle, but if for 2/3 of the price you could play a virtual concert in Seattle, you may as well stay here in Austin and enjoy good restaurants that we have here.
Conventional telephones and video conferencing often leave people so unsatisfied that they travel to meet face to face. Coliseum is a working immersive video conferencing system that aims to bring the realism of face-to-face meetings to remote communication. Multiple geographically dispersed Coliseum users each use a standard desktop PC into which we've integrated 5 small video cameras. In real time, 3D models of the users are generated, assembled into a shared virtual environment, and rendered and textured to unique viewpoints for each user. This allows important interactions like eye contact to be conveyed correctly. The result is similar to earlier virtual world systems, except the avatars look like the actual participants. Every user has a location in the virtual environment and sees a unique view that is appropriate for their location. Users are free to move in the environment, and the views they see are updated accordingly. New view synthesis is a key component of Coliseum and is used to generate arbitrary views of users. To generate new views, the user is first segmented from the background in each camera frame. The segmented portion is projected into 3D and the resulting frusta are intersected. This provides crude geometric models for the users. The new views of users are created by rendering and texture mapping these models. We use MIT's image-based visual hull algorithm that performs these steps at video rates. The inaccuracy of the visual hull models does cause some noticeable artifacts. We've developed a new algorithm, the image-based photo hull algorithm, that uses color information in the camera images to improve the visual hull geometry and reduce these artifacts. Textures can be badly misregistered when mapped to the inaccurate visual hulls, but look much improved when mapped to the photo hulls. The photo hull also usually eliminates the background pixels that often appear around the edge of the visual hull when it's texture mapped. Motion parallax is used to give users the perception of depth. Specifically, a participant's head position is tracked and their display is re-rendered to account for their movement. We exploited the multiple Coliseum cameras to implement a head tracking algorithm that's robust yet reasonably fast. Though initially tailored as a video conferencing replacement, Coliseum is also applicable for uses like distant learning, entertainment, and games. It is a working and usable multi-way realization of immersive video conferencing.